I'm going to show two examples of solving nonlinear systems of equations in two variables. So if I'm given the graph, I can see that the graph of these two equations intersect twice. This one looks like right at 4, 0, and then this one I don't know. It's not on a point there, so we need to use algebra to figure out our points of intersection. All right, so solving a system, we can either use substitution or addition. This one is really nicely set up for substitution, so I'm going to add y to both sides, and that gives me x equals y plus 4, and I'll go ahead and plug that into the first equation using substitution. Okay, so in equation A, I'm going to just plug x equals y plus 4 into that place for every time I see an x. All right, here we go. So x squared, so we'd have y plus 4 quantity squared plus 4y squared equals 16. And then just be careful here, we need to actually multiply that out. 4y squared equals 16. So we got to distribute our y twice and distribute our 4 twice. So we would get y squared plus 8y plus 16 plus 4y squared equals 16. And I'll go ahead and just subtract 16 from both sides. And so that gives me 0. And then I can combine my y squareds. So I've got 5y squared plus 8y is equal to 0. And I can factor out a y there. So 5y plus 8. And then using product property here, I can solve for y. Y equals 0 is one solution, and 5y plus 8 equals 0 is the other one. And then just solve for y, subtract 8 from both sides, divide by 5. Okay, so there's my y's. Now I need to find x. So I'll do that for both of these 2 points. So when y equals 0, I'm going to plug that into equation B. We've got x minus y, which is 0 equals 4, so x equals 4. And that's this first point that we could see right there on our graph. So we've got 4, 0. All right, and now we need the next one when y is negative 8/5. Okay, so in that goes into equation B. We've got x minus y, so x minus 8/5, negative 8/5 is equal to 4. And that would give us x is equal to 4. And I'll go ahead and subtract 8/5 from both sides. We need a common denominator, so we can let it be fifths. So we've got x is equal to 20/5 minus 8/5, which gives us positive 12/5. And so there's that next point right there, which is when x is 12/5 and y is negative 8/5. All right, and so that's how to solve a system using substitution. And let me show you another one using addition method. All right, let's try this one. So this one is well set up for addition because it looks like I could really easily eliminate my x variables. So the first step is eliminate a variable. And I'm going to choose x to eliminate. So if I take basically and just subtract the second equation, so we'd get x squared plus 5y squared equals 25, and then negative x squared plus 4y squared equals negative 16, and then we'll just add up our columns. So these guys would cancel, and I'd get 9y squared equals 9, so y squared equals 1, and then when you take the square root, you need to take positive and negative square root of 1. Okay, so we've got y equals both a 1 and a negative 1. So now when we're finding x, we've got two different things that we need to plug in for y and find the corresponding x values. All right, here we go. So you can just plug y equals 1 into either one equation. I'm just going to choose B. So x squared minus 4 times y, which is positive 1, equals 16. So that would be x squared minus 4 equals 16. Add 4 to both sides, and then take the square root And then you can simplify that. That would be 20 is 4 times 5. So then you could take the square root of 4 and get 2. Square root of 5 doesn't simplify anymore. Okay, so when y is 1, we've got two options for x. It could be a positive 2 root 5 or a negative 2 root 5. Okay, so you can see those are our first 2 points right in there. But we also have a couple more because we also need to show what happens when y is negative 1. And we would get 4 times negative 1 squared. That negative 1 is just affecting the squaring is just affecting the negative 1. So it would be x squared minus 4 times positive 1. So that would still be x squared minus 4 equals 16. And so you end up with the same thing, positive or negative 2 root 5. Okay, so when y is negative 1, we can have a positive 2 root 5 and a negative 2 root 5 for our x value there when y is negative 1. And you can see those are our other 2 points of intersection. So often there's quite a few points of intersection, so all 4 of those ordered pairs is the solution. And that is done.